When you look at the core engines driving AI today, like the GPT models, it's actually kind of wild that the basic decoder transformer architecture hasn't fundamentally changed its approach in what, almost a decade?
It's true that autoregressive step-by-step generation is incredibly dominant.
Dominant, yes, but it has this inherent rigidity. It feels like it's making these huge, high-level choices implicitly, moment by moment, instead of, well, planning ahead.
Exactly, like deciding the whole mood of a story just by picking the next word over and over.
Yeah.
It forces complexity down to the token level.
And that's precisely the constraint we're digging into today. We're exploring a really interesting proposal from Francois Fleuret over at Meta. It's called the free transformer.
The idea is to give the model back some explicit, high-level decision-making power. Break free from just sequential prediction.
It's about injecting that latent planning capability, giving it structural freedom.
Precisely. Planning before speaking, essentially.
Now, before we get into the nuts and bolts of how it works, just a quick mention of our sponsor. If you or your team are trying to get up to speed with AI or integrate these tools, Embersilk is the answer for all your AI education and integration needs. You can find them at embersilk.com.
Good resource.
Okay, so let's unpack this standard autoregressive model limitation. Why is forcing everything into that sequential process such a problem? What's the core issue?
Well, the fundamental thing is that these standard models don't make explicit latent decisions. There's no single point where it decides this output will be positive or this output will follow structure X.
Right. It only ever decides the very next word based on all the words that came before.
And that gets, frankly, unnecessarily complicated when the thing you're generating should naturally depend on some high-level choice made up front.
Like that movie review example you mentioned earlier, a standard model trying to write a positive review.
Yeah, it has to keep pushing the probability towards positive words, token after token after token. It has to bake that high-level intent into every single low-level prediction.
Which sounds computationally expensive and maybe brittle.
Exactly. If it could just decide z equals positive at the start, z being this latent variable representing the overall plan, the generation becomes much simpler, much more direct. Without that, you need a bigger model, more capacity.
And it's vulnerable, right? A few ambiguous words early on could derail the whole thing.
Totally. It can get sent off track, as the paper puts it.
Okay, so here's where the free transformer comes in. How does it use this conditional variational autoencoder, the CVAE structure, to fix this?
It's actually quite elegant. The free transformer conditions its whole generation process on a random latent variable, we're calling it z.
And the C is learned automatically, no extra labels needed.
Correct. Learned without supervision during training. Think of z as the model's internal, high-level concept or intention for the sequence it's about to generate. This gives it that freedom of conditioning we talked about.
So the model learns its own internal plans. And structurally, how complex is this addition? Does it require rebuilding the whole transformer?
That's the really neat part. No. They managed to do it by adding just a single additional non-causal transformer block. That block acts as the encoder, figuring out the z during training.
Just one block? That sounds incredibly efficient.
It is. The computational overhead is tiny. For their 8 billion parameter model, they reported only about a 3.1% increase in computation.
Wow. Okay, usually adding encoders via E structures, it can slow things down, but they seem to have gotten this structural boost for a minimal cost.
It appears so. And the performance results really back it up, especially on tasks where that kind of high-level structure or reasoning matters most.
All right, let's talk results. What kind of improvements did they see with this 8B model?
The gains are substantial in reasoning tasks.
Yeah.
For example, Human Eval plus A, which is complex code generation, saw a jump of over 11%. That's huge.
11%, okay. What about other areas? Math, common sense?
Yep. GSMA-K, a math reasoning benchmark, improved by almost 3%. CSQA, which tests common sense question answering, went up nearly 6%.
And MMLU, the big multitask benchmark.
Also, a solid gain there, over 5% improvement. So across the board, especially where structure and reasoning are key, you see a real benefit.
So the takeaway is that this latent variable z fundamentally improves the model's what the paper calls its inductive bias.
Exactly. It helps the model generalize better because it can explicitly learn and reuse these high-level structural concepts encoded in Z. It leads to smarter, more structured outputs.
It's fascinating. It feels like the free transformer is doing something in latent space, this hidden Z space, that's kind of analogous to what methods like chain of thought try to do explicitly in the token space by writing out reasoning steps.
That's a great way to put it. One provides structure implicitly through latent variables, the other explicitly through generated tokens.
Which leads to a really interesting question for you to ponder. What happens when you combine these two approaches? What new capabilities might emerge if a model can plan both latently and explicitly generate its reasoning?
A very powerful combination, potentially. How deep can that structural planning go?
Definitely something to think about. And on that thought, we'll wrap up this deep dive. If you found this useful, if you appreciate getting insights like this straight from the research, please do subscribe and maybe leave us a 5-star review.
It genuinely does help us keep bringing these analyses to you. Thanks for tuning in.